Hello and welcome to the newest installment of Raritan PowerTips Live. This webinar series is designed to provide live technical support demonstrations as well as the opportunity to ask questions and have discussions with our team and fellow participants here. My name is Ellie Byrne. I'm a marketing specialist at Legrand, and I'm joined here by our host, Duncan Gwen, our technical support engineer at Legrand. In today's live technical webinar, we'll be discussing SNMP versions, downloading MIB and structure overview, finding SNMP object IDs for inlet and poles or phases and outlets or different sensors. Feel free to post any questions in the Q&A or chat sections throughout the presentation, or wait for the end when we open microphone access to the participants for questions and discussions. If you have any other pressing issues, you can always visit raritan.com/support. And with that, I'll pass the floor to Duncan to begin.
Thank you, Ellie. Thank you for joining today. And if you joined us for our previous webinar in May, welcome back. We hope that you find these valuable, and we look forward to sharing some knowledge with you. So as Ellie mentioned, today we are discussing how to find SNMP object IDs. And before we dive into that, I always like to get started with some definitions. So SNMP is the Simple Network Management Protocol, and it allows us to manage devices on our network by collecting information, controlling the device where applicable, and receiving alerts when events take place on those devices. So the typical structure of what you might see is an SNMP manager. This may be something like a data center infrastructure management tool or some other piece of software that will pull SNMP agents. And the agents in our case are going to be rack PDUs, but they could be things like network switches or routers or other devices that support the SNMP protocol. So two important components of SNMP are going to be MIBs and OIDs. The MIB is a management information base, which is a text-based file that defines the structure of supported objects for an SNMP device. Performing an SNMP walk or a MIB walk against your Xeris platform product, such as a Raritan PDU or Smart Rack controller, this will identify what objects are available for your model. That will vary depending on what that model supports. An example would be you may have a PX3 1000 series PDU that has inlet level metering, and you may have a separate PDU that is outlet level metering with switching capabilities. And that will, of course, have more objects that are available when we pull that device via SNMP. And the OIDs themselves, these are object identifiers, and it is a string of dot separated numbers that will point to those specific objects. You can think of it like a specific address to reach that particular sensor or object that we're after. So I will go ahead and dive in. One of the first steps of going and pulling via SNMP is, of course, setting up SNMP on the PDU itself. So I'm going to log into one of my demo units here. And in the device settings menu, which was already there somehow, if I go into the device settings menu and go into network services, SNMP, you'll see that we have the ability to enable an SNMP agent here. Now, depending on your firmware version, the factory default behavior is for this agent to be disabled. You do have to enable it. So I've already enabled it on this particular unit. I'm using SNMP v1 v2c. You can enable the SNMP v3 agent. We're not going to discuss SNMP v3 today because the OIDs are still the same, whether you're using version 2C or version 3. That's not relevant. For simplicity's sake, we're going to use v2c. So I've defined some community strings here, which are essentially passwords that give us permissions to read or write to the device. And we have the read community string as public and the write community string as private. So we'll demonstrate some objects that we can write to when we look at the MIB browser. And further down, we'll see SNMP notifications. So these are traps or inform messages that you can set up, and this will send a message to your SNMP manager or trap receiver whenever an event takes place on the PDU. So I went ahead and I set this up with the IP address of the computer I'm going to be polling from, because I do have a trap receiver on that machine. So we can demonstrate what it would be like to receive an SNMP trap and some of the variable bindings associated with that. So now that we have that set up, we need to obtain our MIB file. And there are a few places that we can get the MIB file. If you look at my screen at the bottom, you'll see a download MIBs section. I can expand that, and you see I can download the PDU2 MIB or the asset management MIB. So the primary MIB in our case is going to be the PDU2 MIB. The asset management MIB is specific to our asset management strip product. So if you're using that alongside your PDU or Smart Rack controller, that would be a valuable MIB as well, so that you can manage your asset management strip and tags. In our case, we're only looking at the PDU2 MIB. So I've already downloaded it, so I'm not going to download it here, but I do want to show you another place where you can obtain those files. If you go to raritan.com/support, you can scroll down and you can either choose a product from our drop-down menu, or you can look at our most viewed products. So I'm looking at a PX3 PDU. The PDU2 MIB covers a wide variety of products. So it's the same MIB file for PX4 as well as the PX2, PX3 series products. So the product page that I go to doesn't matter so much in this case, but we do recommend that you always have the MIB that is the equivalent for the firmware version that you're using on the PDU. So if you download that from the PDU GUI itself, you can guarantee that it's going to be the MIB file that is relevant to your firmware version. So in the SNMP section of our support page, we have a few documents. You'll see that the PDU2 MIB and the asset management MIB are both here. And then we also have a MIB user guide. And quickly, I want to look at this MIB user guide, because it is a fantastic document that you can reference that provides some high-level guidance of how our MIB is structured and some important things to take note of. It also provides a quick start MIB guide, so you can have some SNMP commands that you can issue utilizing a command line utility from Net SNMP tools. So we have various command examples in this document, and it really provides a lot of information in terms of the MIB structure and some of the important OIDs that you need to take note of. So I've downloaded our MIB already. I'm going to transition over to our MIB browser. And I'm using a product called iReasoning MIB browser, and it is a GUI-based MIB browser. So it is very user-friendly, and it provides us with a way to kind of navigate through the structure of any MIB files. And the first step of reviewing a MIB is, of course, loading the MIB file itself. If I look at the file menu, I can load a MIB and navigate to where I've saved that. But in my case, I've actually put it in my MIBs folder, so you can see that I've loaded one in here already. And after you load the MIBs, you'll begin to see this structure. So at the very top level here, you'll see that it's iso.org.dod.internet, and that gives us our base level OID here. And for Raritan PDUs or server technology PDUs, these are going to live in the private enterprises portion of the tree. So if I expand this, you'll see that as with each folder, I have an additional numeric value representing what that means, what it translates to. So each company will have a private enterprise number. So you can see here that our server technology brand has a private enterprise number of 1718, and the Raritan brand is 13742. And if we expand these, I've only loaded one MIB for each brand here, but you can see that any relevant MIBs to each private enterprise would be under this tree. So our PDU2 MIB supports, like I mentioned, a wide variety of products, but our previous generation MIB, the PDU MIB, was for the first generation PX PDU, which is very old at this point. So we're not going to be discussing that. We're only going to be looking at the PDU2 MIB. As we expand this, you'll see again that my dot notation for my OID keeps changing as I navigate through these different levels or subtrees of the MIB. And within the PDU2 MIB, we have 7 main sections or subtrees. We have traps, configuration, control, measurements, log, conformance, and reliability. Now, we're really only going to focus on 3 areas where we see a majority of questions come through where people are interested in getting information. We won't be touching on the conformance and reliability much. I will mention the log portion of the MIB briefly. But we'll go ahead and start with traps. So we'll dive into some of this later, but as I mentioned, traps are messages that the PDU will generate and send to a trap receiver. And this portion of the MIB will tell us what traps are supported. Not every product will support all these traps depending on what sensors it has and what it's configured to do. But these are all the possible traps that a Xeris platform product could generate for this firmware version. And if we click on a trap, we'll see in this window down here some objects, and we can see what we might expect to receive along with that trap message when we receive it. So we'll look into some of these objects a little later once we do an example of receiving a trap. But this is how we can navigate through it and look at things. We have, of course, this tree structure, and then some syntax and various objects that we can look at in the window down here. And when we look at the configuration portion of the MIB, that is going to cover objects related to PDU details, like serial number, firmware version, outlet count, all things that would tie to the actual configuration of the PDU. And that includes like sensor thresholds. If you wanted to modify sensor thresholds and stuff via SNMP, it would be in this configuration portion of the MIB. So if we drill down further, we can see that we have a number of subtrees under the configuration group. And we'll kind of see a similar structure for each subtree where we have a unit level, which is the PDU level, inlets, overcurrent protectors or circuit breakers and fuses, outlets, external sensors, which would be your peripheral like temperature, humidity sensors or smart locks, things of that nature, and then some other features of the unit or the PDU itself. Some of these don't apply to rack PDUs. Like for example, we have OIDs that are specific to transfer switches. And then we have power meters and circuits, which are specific to the branch circuit monitoring products. But we can see that if we expand these menus, we have additional tables that will provide us with all these details. And we can, perform some SNMP gets to get some of these information. If I get a subtree, that will get everything in this folder. It will, basically do an SNMP walk just at this level. So if I do that, you can see that it went through it pretty quickly. But I can see for each OID that I pull, I will receive a value. I will receive that type for the value. So some are octet string, some are integer, IP address, basically the data type that we're expected to get back. But I could find these details. So this is a quick way that you can maybe get some OIDs, pull them, and map it back to the value that you're expecting. So an example would be the firmware version, which I believe is mapped to what we call the board firmware. And we can see board firmware version. We can see the firmware version of this PDU here. So that might be a valuable OID that you would bring into your external system just so you know where your PDUs are at if you need to upgrade things. But of course, model and serial number, and then the PDU ratings itself. So with the voltage that it's rated for is in the current. Those are all things that are valuable to bring into an external system. And likewise, we can clear this table out. We can look at the configuration for inlets. So if I expand this, you'll see that I have a lot more information regarding just the inlet of the PDU. So I can check its plug type. We can see that this one's a C20. I can see what the inlet rated voltage is, the inlet name, which I don't have one defined, but our icons here that have a leaf, we can see that these have a access level of read only. So I can only obtain the values for these OIDs. Anything that is labeled with a pen and paper is something that I can actually write to. So if I wanted to change the inlet name, I could do that. A more common use case would be changing the actual PDU name itself, which is under the unit configuration. If I double click on this, I can see that my PDU name is currently set to the default value of my PDU. In this MIB browsing tool, I can right click. I can select that I want to set that, and I can change the name to some name that is more meaningful to me in my data center. You can see that the set succeeded. Now we don't immediately see an update here because this is an old value based on our last poll. So if I pull that again, I see my new value present. So again, the configuration portion of the MIB is going to contain all those values related to the actual configuration of the PDU, inlet, plug, and I mentioned briefly thresholds. If you look at the inlet sensor configuration, you can see we have a variety of sensor thresholds that we can set. Won't dive into the adjustment of thresholds much on this call. The next major section of the MIB is control. So this is going to allow us to control supported objects, probably the most common being an outlet control command. We want to power cycle outlets on PDUs that have switching capabilities. If we expand the outlet control section, we can see that we have in a switching operation OID here. And when we look at this and click on it, we can see the numeric form of the OID listed here. And in order to make use of this OID, it's going to require that we pass some indexes and some information along with it. So we see some syntax information and some indexes here at the bottom. Now, if I just double click on this in the MIB browsing tool, it will perform a walk. And this is a 24 outlet PDU. So it go ahead and it gets a switching state for all 24 outlets of my PDU. Now, if I wanted to make a change where right now I have outlet 24 in the off state, I can right click on this and perform a set command again. But before I do that, I just wanted to point out the indexes. So at our base OID, we can see a switching operation. And then after that, we have some index values. The first one is PDU ID. So you can see for all 24 outlets, we have a PDU ID of 1. Now, if I had my PDUs in a linking configuration where I had more than one unit connected together using the link feature, I would see that PDU ID increase to the number of total PDUs that I have. And then the second index is the outlet ID. So, outlet 1 has an outlet ID of 1, so on and so forth, till we get to outlet 24. So those are things to keep in mind because these indexes are very important as we get into some of the measurements and other portions of the MIB. So if I want to issue a set command for this outlet, I can click on set, and then I can see that it pops up with the OID, the data type that I'm sending when I issue this set command, which it automatically selects the appropriate data type for what we need. And then you can see the last is a blank field for value. And grayed out, we have the possible values for the outlet switching operation, which we support sending an off command, an on command, or a power cycle command. So if I wanted to turn this outlet on, I'm going to use the integer value 1 and send that, and we can see that the set succeeded. But again, we don't see any updates here because this is an old pulled value. I can double click on that same operation and see that it's in the on state now. So that is how we can issue some control commands to the PDU to control things like outlet state. Now there are other, a lot of other sensors that could be controlled, like actuators or smart locks that you may toggle the state of. And then you'll see a wide variety of different subtrees here that are related to some other products, like transfer switch control. If you wanted to switch inlets of a transfer switch, you could do that with SNMP. And then there's some that are maybe less obvious, like inlet sensor control. These are mostly going to be used for resetting like min-max values. So we can reset some of the historic values that we have stored in the PDU. But the primary ones that we see are going to be related to outlet control, external sensors, and actuators would be the primary use case for the control portion of the MIB. Now, if I go down to the measurements section, now this is probably where we get the most questions and probably where most OIDs are going to be pulled, because this gives you all of your PDU sensor measurements. And if we expand this, we see kind of the familiar structure that we've been seeing in every subtree, where we have unit, inlet, overcurrent protector, outlet, external sensor, etc. Again, these other portions are not relevant to this particular product, with the exception of outlet groups. So we're going to ignore a few of these. Now, I'll start with the inlet level, because that's going to be one of the more common tables that we look at here. And if we expand the inlet sensor measurement table, we see that we have a variety of different endpoints or nodes that we can pull here. And we have inlet sensor value. We also have an inlet sensor signed value down here. So the MIB user guide talks about why you may want to use a signed value versus an unsigned. The most obvious use case is going to be if you have a sensor that is capable of having a negative value, you're going to want to use the signed OID. An example of that would be like phase angle of your inlet. If you have a 3-phase PDU and you're monitoring the phase angle, you're going to want to use the signed value because that sensor has the potential to be negative. But sensors like active energy that are a counter that's always increasing, you would use the unsigned value, and it can store, unsigned integers can store larger positive values. So if I double click on the sensor value, I immediately get back a variety of sensors. And right now, I have no idea what these sensors mean. So we have our indexes again. We have PDU ID, we have inlet ID, and we have the last index, which is sensor type. And that's going to be the key to understanding these values, the sensor type enumeration. So in the MIB browser tool, if we look at the configuration, we can see the syntax of a sensor type enumeration. It's actually in this external sensors table. But we can reference this full enumeration table. Now, I've taken some of the key enumerations out of the MIB browser tool, and just for quick reference, have pasted them into a spreadsheet that we can look at. But we can see that there's a wide variety of sensors that are supported on the PDU. 79 different sensors. Now, some of these are related to external sensors, and some of them are related to newer products like the PX4 and Pro 4X that have some more advanced power monitoring features. So you're not going to see every sensor type on every PDU, but we can see some of the key sensors are going to be RMS current, RMS voltage, active power, apparent power, power factor, active energy, etc. So, we see all these sensors come back when we pull that inlet OID, and we have some values associated with those. Now, the next portion of interpreting these values, now that we have an idea of what sensors they belong to, is to understand how we are supposed to scale these and what units these sensors utilize. So going back to our configuration portion, if I look at the configuration of my inlets and expand my inlet sensor configuration table, I can see I have some OIDs here. The next one that I want to look at is our inlet sensor decimal digits. So if I double click on this, it will pull this OID, and I get the same number of results back, of course, with different values for inlet sensor decimal digits. This tells me how I should be scaling my various readings. So for the inlet RMS current, I should be scaling this by 3 decimal points. So my value here is 7075. I don't have 7,000 amps on the PDU. I have 7.075 amps on the PDU. For RMS voltage, there are no decimal digits. So the value that I retrieved back, 112 volts, is accurate. I don't need to scale that. Active power, parent power, those are also 0. Power factor gets scaled by 2 decimal places. So I would have a ratio for power factor. It's 0.86 would be my power factor on the inlet. Active energy, again, does not get scaled. It's a counter. And then the last one is our frequency, which in this case would be 60.0 hertz. Now, I know those units because I'm familiar with which units belong to those particular sensors, but if you are putting this into a system where you want to obtain those units automatically and make sure you're utilizing the correct unit, you can pull the inlet sensor units OID. And again, we get the same number of results back for each sensor. And we can see that this is also an enumeration where we have amps for RMS current, utilizing volts for RMS voltage, watts, voltamps, no unit for power factor, watt hour for active energy, and then hertz for our frequency sensor. So those are ways that you can quickly reference the sensor units and make sure that you are using the appropriate unit there. That will come back to the sensor units when we look at some of our external sensors. But the next section of our measurements table is actually overcurrent protector. Now, this particular PDU that I'm pulling right now does not have an overcurrent protector. So if I try to obtain anything from it, I'm not going to get anything back because there is no overcurrent protector. So we'll come back to this one and look at a different PDU here in a bit. Measurements outlet is going to be very similar to our inlet measurements. We're going to have a variety of supported sensors depending on what our PDU is. And I can again double click on outlet sensor value, and I get a bunch of sensors back for each outlet. So, I have basically the same number of sensors that I had with my inlet, with the addition of one on-off sensor. And we can interpret it the same way. So we can use the PDU ID index. Now, instead of an inlet ID index, we have the outlet ID. So we're going to see values from 1 all the way to 24 for our 24th outlet, and then our sensor type. And again, that's going to map back to our sensor type enumeration to determine what sensor we're wanting to look at. If we're just wanting RMS current, we'd look at dot 1, active power, dot 5, again, mapping back to the enumeration table that is defined in the MIB itself we have here. The other thing that we might be interested in is the sensor state. So we have a sensor state enumeration, and alongside the sensor values, you'll see that we also have outlet sensor state. So if we double click on that and pull that, you'll see that we get all the states back for these various sensors. So we can see that our on-off sensor is a state sensor. It's not a numeric sensor, so we don't we got a 0 back when we did the value because it's not a numeric value. But it does have a state association, which it is currently on. And then if we had any thresholds defined on the PDU for these outlets that were crossed, we would see that these are no longer normal, but if we crossed over a lower critical or upper critical threshold, we would see the appropriate state show up there. So those are values that you can expect to receive back from the outlet state sensors. Now I'm going to transition over to our PX4 product, and we will look at the overcurrent protector sensors here. Just got to put in my community strings, set my version. So going back to measurements over current protector, again, we're going to have various sensors that we can pull here. The most common being, sensor value and sensor state. Now, if I double click sensor value, see that I have, again, a very similar structure with indexes where I have a PDU ID, and now instead of an inlet or an outlet index, I have an overcurrent protector index. So this particular unit has 3 circuit breakers, and each circuit breaker has 2 sensors. The first one being RMS current. Again, we can reference our sensor type enumeration table. Mouse keeps disappearing on me. So our sensor type enumeration table shows us that .1 is an RMS current. And then we also have a .15, which is a trip sensor. So if the circuit breaker trips and goes into an alerted state, this sensor would be alarmed here. Now, this is also not a numeric sensor, so the 0 that we get back is not relevant. We would need to pull this as a state sensor to verify the current state of that trip sensor. Now, it looks like someone has adjusted some of the thresholds on our RMS current sensor. So these are showing that they're in a below lower critical state right now. Typically, the default thresholds for RMS current on a circuit breaker, you don't have a lower critical or a lower warning. You're only worried about, current above a certain point. But those thresholds must have been enabled, which is why we see them in this state. But we can see for our trip sensor that all 3 of our circuit breakers on this particular PDU are closed and not in an alarm state. So the last major section of the measurements subtree would be external sensors. So again, the external sensors are going to be related to things like temperature, humidity sensors, contact closures, smart locks. And when we expand this, again, we will see kind of the same options that we have for each of the other levels, where we have values and states, signed values as well. And I can double click on these and see here that I've got a variety of external sensors. Now this one is a little bit different than the ones that we've been looking at, because now we still have some indexes, but we have PDU ID and we have sensor ID. So the key here is understanding what sensor IDs you have in the PDU. Now you may have different configurations and different sensors on each of your PDUs. So if I go to our web interface of this unit, I'll show you what that maps back to. In our peripherals menu, we see here that I have 17 peripheral sensors on this PDU, and they're in a variety of states. I have yellow warning, red for critical, and all the others are normal. But I have temperature, relative humidity, absolute humidity, dew point, etc. So a variety of sensors. Each one of these has an associated number. Now, depending on how I've configured my PDU and how I connected the sensors, these sensors might have different IDs. So, in a data center environment, you'll see oftentimes that things are standardized, and you'll, connect the temperature sensor first and then the contact closure, or whatever sensors you're chaining together. They will follow a typical kind of build, in which case you should have very similar IDs. But you may have a case where maybe they weren't installed in the same direction or order, and things got reordered, and now you have different sensor IDs. So when we go back to our MIB browser, if we look at our configuration and our external sensors, we have an external sensor type OID. Now, if we pull this value, we'll see that, again, we get 17 values back for our 17 sensors, and we can see what they are. We can see that 1 maps back to a temperature sensor, 2 is humidity, 3 is absolute humidity, dew point, so on and so forth as we go further down. And then we can also look at the external sensor units. I'll just clear this out to clean things up. And we can see the units that we would be utilizing for each one of these sensors. So our temperature sensor is set to degrees Celsius. We have a percentage for our relative humidity, gram per cubic meter for absolute humidity, and so on and so forth. So these are all important, and they all play together to understand how you would interpret the values. And as we looked at with our inlet sensor and our outlet, we do have the decimal digits as well. So when we pull this value, we know what we need to scale these sensors by. So for our temperature, we would be scaling that by 1 decimal point. And just to illustrate that again, if I go back to my measurements and my external sensor and value, I see a reading of 252. So it's not 252 degrees, it's 25.2 degrees Celsius. So it's important that we interpret that with the decimal digits. Now, one last thing that I wanted to talk about in this measurements table, we're kind of looking at a single phase PDU for a majority of that. Now, questions that come up often are regarding 3-phase inlets. Now, if I'm connected to this PX4 now, which is a 3-phase PDU, if I pull my inlet sensor values, and I see a variety of sensors come back with different readings, but I see I only have one RMS current sensor and one RMS voltage. Now it's a 3-phase PDU, so I'm trying to figure out how I can get my other poles. Now we have a separate sensor table down here for inlet pole sensor measurements. So these right here are really only for convenience. So the RMS current at the inlet sensor level is always going to show us the highest current on any one of the 3 phases. And our voltage is going to show us the lowest RMS voltage on any of our 3 line pairs. So it gives us a quick reference if we have, a voltage issue or, issue with one of the poles being close to its current capacity. We can quickly see that. But for long-term polling, we really need to look at inlet pole sensors for a 3-phase PDU. I'll minimize this. And again, we have inlet pole sensor value. When I double click on this, I get a whole bunch of readings back. And we see here, if we look at our indexes, PDU ID, inlet pole index, and sensor type. So again, understanding the enumerations and mapping those correctly is going to, unlock what these sensors are. Now, in my case, I'm curious about inlet pole RMS current, which would be 1. And again, this is scaled by 3 decimal points, so there's next to nothing on this PDU right now. 0.019 amps on the first pole. RMS voltage, 195 volts. And then I would find the same information for my second pole down here. So 0.094 amps, 197 volts, and pole 3 is down at the bottom. So that is, again, a common question that comes up, when we have customers that are adding 3-phase PDUs to their SNMP systems, obtaining these values, and it's done in the inlet pole sensor value table. So the last thing that I wanted to cover, I mentioned we were going to receive a trap from a PDU. So if I just transition back to my single phase unit here, make sure I enter my community string so it doesn't yell at me. And the iRacing MIB browser has a trap receiving tool built into it. So if I turn that on, clear this out, looks like it was already running. Now I can trigger a trap to be sent to this trap receiver by going into the outlets menu, the control outlets menu. I'm just going to switch an outlet into a different state. I'll look at switching operation and I'll turn outlet 24 off. So we'll do a set. We will use the integer 0 to turn it into the off state. We can see that it succeeded. Now, if I look back at the trap receiver, I see that I received 2 SNMP traps. So I received a power control trap. And within that trap, we have a variety of variable bindings associated with it that give us information about where the trap came from. So we can, of course, see that it came from the IP address of the PDU, but we do have other details like the PDU name, which I can see I changed to PowerTips, the username of the person that performed the power control operation. In this case, we did it via SNMP, but if someone was logged in as the admin user or a separate user, we would see their username here and know who turned that outlet on or off. And then, again, there are a variety of different var binds in here indicating the outlet number and the state that it changed to. So all this information will be parsed by your SNMP trap receiving system so that you could log that appropriately and take action if necessary. And the same would go for, crossing a threshold, but rather than receiving information about power control, we would see that, an outlet sensor state went into a critical state. Now, in this case, we do get a trap for a state change, but it is specifically related to the type of sensor on off. So we know that our power state of the outlet changed. But yeah, if we, had a circuit breaker go into a trip state and it was now, open instead of closed, we would see a overcurrent protector sensor state change. We would see the type of sensor would be the trip sensor, which is 15. And we would see the other information about what state that particular circuit breaker is now in, whether open or closed. So that is really it for the live demo. I think we can open it up for questions now and address any specific OIDs you guys want to see or questions that you have. So Ellie, I'll turn it back to you.
Thanks, Duncan. I just put microphone access on for all of our participants. So if you have any questions, feel free to come off of mute and ask a question or share any comments you have. That's fine too. Or there's the chat and the Q&A sections as well. So we'll give a couple moments and see if anything comes through.
I have a question.
Sure.
So I've been following along with your demonstration using the iReasoning MIB browser. And whenever I imported the MIB files from the website, I noticed that I had access to that PDU2 folder, but the enterprises folder with Server Tech and Raritan, those were not populated. So I don't know if I need to manually create those or if I did something wrong. Am I uploading? Any thoughts on why I have access to my PDU2 folder and I can do my gets through the software, but the enterprises, Server Tech and Raritan, I don't see those?
So I'm not an expert on the iReasoning software, but I think I've dealt with that in the past, and I think it might be related to what you have loaded so far. So, if we kind of look at my structure here, I have this main folder because I've loaded some of the management MIBs, like, the MIB2, IFMIB, and then I loaded both Server Tech and Raritan. So the more MIBs you load, the more it will kind of separate things out and give you some more folders to drill down into. But if you only load the one MIB, then I believe it's just going to show you a long string of everything for PDU2 MIB because that's the only subtree that you have, right? You don't have anything else to drill into. I think that might be it. But again, I'm not an expert in software by any means.
Yeah,
Thank you.
Yeah, and the other reason could be that if you're using a free version, then it might have a limited number of, how many MIBs you can load, right? So you might be exceeding that number. I believe it's 5 or 10, 10,
Yeah,
right?
10 MIBs.
So you might have to unload one of the other MIB and then probably you will see it there.
Yeah, just to provide you with a quick example, I just unloaded the management MIBs, and you can see how it changed on my screen. Now I only have private enterprises at the top. Now, if I unload the Server Tech MIB, this is probably what you're seeing, right? Just Raritan PDU2. In which case, now that's the only thing that I have in my tree, so I don't have anything else to expand to. But if I go back and load, the IF MIB, for example, now it takes me to this top level where I see some more information.
Gotcha. So I'll play around and experiment. Thank you. I appreciate that.
Yep, no problem.
I've dealt with that before. The maximum you have is 10, and you do have to delete some of them to use another one.
Yeah, so I'm utilizing the enterprise version, so I don't have a limit on the number of MIBs that I can have, but you can see that I've only loaded a few. But yeah, it's it's the MIBs that you have loaded are kind of going to determine the tree structure that you have in the software. One thing that I did want to mention, if we don't have any other questions,
I have one.
this is something. Oh, go ahead.
We use a network monitoring system called SolarWinds. Within SolarWinds, there's this concept with what they call a polar. The polar is really just a grouping of SNMP OIDs that are grouped specific to a type of hardware, a certain model, right? Do you have any like canned SolarWinds polars prepared for any of your products, or is that something we're just gonna have to build on our own?
That is not something that we offer. Now I know, we have some customers that are also utilizing the SolarWinds platform. So I would, if you've not reached out to SolarWinds, maybe they have something in their database that they could share, but we do not offer like a canned SolarWinds polar. I think everything that I've seen has been either built by the customer or possibly obtained from SolarWinds.
Got it. Thank you.
Yeah, no problem. So one thing that I did want to share while we've got some time, this will be the last thing that I share unless we have some other questions that pop up, is I showed how go back to my PX4 here. I showed how, the external sensors, we had units for our temperature sensor. And in a more recent firmware version, we now offer support for changing the units from degrees Celsius to Fahrenheit, which, some customers want to see in their SNMP management software. So if I go back to my external sensor measurements and, just pull that value, if I was interpreting this correctly, rather than having my, SNMP management system do all the math for me and convert it to the right value, I can actually go into my PDU configuration, my GUI here, and in the user management menu, we have some default preferences. And you can see there's a note at the bottom here, and these default user preferences apply to the display of the PDU, so the LCD screen, SNMP, and some of the other features, and users that authenticate via remote authentication would be applied these default preferences. So if I change these to values that I want to see, I should now see in my nib browser, if I pull these OIDs, that I get the expected value in Fahrenheit. So now instead of 25.4 degrees Celsius, I get 77.4 degrees Fahrenheit. That's another common one that we see come through in the support tickets. Don't see any other questions in the Q&A or in the chat. Yeah, feel free to speak up if there's anything else that you had questions on.
Do you know if the data available using the internal Prometheus exporter is going to be expanded to include some of the more common things that are available through SNMP, or is SNMP going to remain the primary method you guys suggest for monitoring?
So I think in terms of the Prometheus exporter, I don't know what is going to be added. Now, if you have something specific that you're looking to see in the Prometheus exporter, feel free to ping us at tech@Raritan. I'll throw our contact information up here. And we can, create a ticket with our engineering team to see if that's something that we can implement. But yeah, the Prometheus exporter is primarily right now limited to, the main numeric sensors of the PDU. We don't include any state sensors or anything of that nature. So if that's what you're after.
Yeah, I think as far as numeric sensors goes, it probably includes everything we'd be looking for, but the only state sensor included was tripped breakers.
Yeah.
And we definitely want to monitor some other state type.
Okay.
Things.
Yeah, so you can send us an email at tech@Raritan, and we'll look into that for you. I am not personally aware of anything on the horizon regarding the Prometheus exporter, but we're always looking for feedback and ways that we can improve that. So we'll take that up with engineering and product management.
Sounds good. Thanks.
I have another question.
Sure.
On the Sentry MIB OID tree downloads on ServerTech website, the Pro4X link, it indicates to click here for the MIB and OID tree downloads, but after clicking it, it simply has firmware release. Am I missing something, or has that not been uploaded yet, or is it expected for those Pro4X PDUs that we download the MIB files from the devices themselves?
It should be available on the support page. So if we look at, are you in the MIB and OID tree download? So it takes you into this page and it says click here. And then once you get into the individual firmware pages, you'll see more links. So once you click in here, you have SNMP and, you have the PDU2 MIB user guide, etc. So those, you can download them here. So I think
Perfect.
you just needed to go one step further.
Gotcha. I appreciate that.
Yep, no problem.
Okay, it looks like we don't have any other questions in the chat and Q&A. So unless there's anything last minute that anyone wants answered, I think we can wrap up. Okay.
Thank you.
Yep, thank you guys. And this recording will be available on the Raritan PowerTips Live landing page, which is just raritan.com/PowerTipsLive if you need to access that. And also feel free to reach out to Raritan support. You can find that information as you see here, or also at the raritan.com/support page. And thank you all for joining, and those who participated as well.
Thank you.
Thank you. Bye.
Thanks again.